Today we are going to do Algebra 1.5, which is the factoring of polynomials. Now, as always, being that this is a review chapter, please look at this stuff and see if you know this stuff inside out. If you think, oh yeah, I totally know this stuff, right? And then you don't have, if you know this 100%, then you can skip this section and this video. If not, then please finish the video and do the homework so that you know this stuff inside out, because this is extremely important for your success or failure and for the entire rest of this algebra course and everything beyond too. Okay, this is like the what they call it, building block, yes, of understanding algebra and everything after it, including calculus. So having said that, let's go to the book and look at what we're going to do today. Now, first, let's go to page 59 and 60. Let's consider the factoring out the greatest common factor. As an example of that, let's look at example 1. Now, example 1, we have, for example, an expression of 6. We have, for example, 6x cubed plus y cubed. Yeah, give me a second. My pen is no good. Continuing, we have 6x cubed y cubed. I'm looking at example 1 on page 60. So we have 6x cubed y cubed plus 45 x squared y squared, and then plus 21 xy. Now, to factor this thing as best we can, what we're going to do is first look at the numbers and see what common factor the numbers have. Did I say 45? It says 45. All right. And what kind of common factors do the numbers have? The common factors, this is like 3 times 2, okay, which becomes 6. This is 3 times 15, which becomes 45, and 3 times 7 becomes 21. So the common factor for just the numbers, that is the coefficients, simply only 3. Okay, there is no other common factor. So 3 is the common factor for numbers. And then let's see what kind of common factor does it have in terms of x's. Well, for x, it has x cubed, x squared, and just x. So the only common factor that everybody has, each of these things have, is just x. Now remember, anything that's being multiplied together is called one expression. Okay, and when then we have a plus, then it divides, or minus, it divides it into a next expression. And that's how we consider each group. A group is anything that's multiplied or divided together. It becomes one expression, and that's all we think about. So let's see. So being the x is the only common factor, and consider y. What about y? Which is the common factor? Well, the only y they all have is just one y. Okay, they each have y as a common factor, not y squared, not y cubed, because this thing doesn't have a y squared in it. It only got y. That's it. So 3xy is the greatest common factor, and we will take that out by dividing. So 6 divided by 3 is we'll have 2 left, and then x, you take x out of x cubed, that you have x squared left, and then take y out of y cubed, so then you have y squared left. That's just for that thing. All right, and then next we have 45 taking out 3, that has 15. Okay, and then x squared, you take out x, then you have just an x, and then y squared. Okay, and then you had taking out y, you have just y left, and then plus eventually this is the same way. So we have 27 divided by 3 gives you 7, and then there's xy got taken out, then it's got nothing. So this is the end of this factoring. Now you notice that, so that is the right answer. You notice that, well, the only thing it has in common, well, what I mean is, to do the common factor, you have to make know that the reason this makes sense is because when you multiply things back out, it will get back to this, okay? For example, if you take this, multiply that by this one, that will be the 6x cubed y cubed. And then 3 times this 15 is 45, etc. And then 3 times 7 is 21xy, because all this stuff multiply out. So the factoring basically is the reverse process of what we did before of multiplying polynomials. Okay, now we're going to work backwards and factor the thing out. So please do example 1, which is this thing, as part of your homework. Try to do it yourself without looking at the answer and see if you can reproduce the same effect. Now let's go to the next page, page 61, example 2, where we're going to do factor something that has the highest power of 2. Now before we do that, let's make something up. Okay, let's say we have multiplied by x plus 2 times 2x minus 5. This is something similar what you did in the previous section. Now how would you do that? Well, first you take the first term and multiply by each one in the second term. So we have 2x squared, okay, x for the first one, and then x with the second one, that would be minus 5x, right? And then x, so the first term is done, and then then we'd work on the next one. The next side, shake hands with the first guy in here, and then that which is plus 4x. And then finally, it multiplied the second guy, shake hands with the second guy over here, which is minus 10. And if you can write this down as 2x squared minus x, and then minus 10, right? If I got 4 minus 5, yeah, I think that's right. Now the question is, here's the trick. Okay, now let's say I give you this thing, and I want you to decompose it back into that. Now, how would you do that? The way you do it then is well, you just have to, that if it can be done, okay, it cannot always be done, but this way anyway. So, but if it can be done, it'd be x here and x here. But I'm trying to re-engineer this thing out. Okay, we have only the sum. How do we go back to the factor? Well, you just stare at it, and you know that it has to have, so we have 2x minus x minus 10. Well, you have to come up with some kind of a number system. So we have the numbers here being, it has to be either 2 times 1, okay? There is no other option to get to this 2 point, okay? And then what about that? Now that we can have certain options. We can have 1 and 10, right, to become negative 10. But if we have 1 and 10, then 2 times 10 is 20, and then minus 1 or something, that's too much, because we only got 1 here. X only has 1. So that is not going to work. So what about 10 and 1? Now 10 and 1, so 10 times 1, okay, and then 2, and that gives us 8. That's still too much. So next, let's try 2. What are the factors of 10? Is 1 10 or 2 5? Okay, let's try 2 and 5. Now if we have 2x, and then 2 times 5 is 10, and then 2, that's still that's too much. So then 10 and you have 10, and that at most got you 2, so 10 minus 2 is still 8, and we only got 1 here. So finally, we try 5 and 2. If we try 5 and 2, then we have 5 times 1 is 5, and 2 times 2 is 4, okay? And at that point, then that will give us a 1. So we have 5 here, okay, and then 2 here. That will give us a 1, and 5 times, so what we're going to do is 5 times 1 is 5, 2 times 2 is 4, so we have a plus here and a minus here, because the minus 5 is going to, so that will give you minus 5, okay, and then plus 4, which gives you minus 1. So this is a matter of beating around until you get this thing to come out, basically. And that's how you do this kind of problem. So with that, please do example 2, okay, which is this type of problem. Is you have 3 things with x squared, and then some kind of x, and then some kind of constant. And they all work this way. If they work, they don't always work. But you just come up with all possible combinations and then see which one's going to come out. So that covers covers example 2, which is, example 2 is an easy one because this number is, up here is 1. Okay, that makes it slightly simpler. And example 3 is when the number here is not 1, but you work on it the same way. You manipulate this thing until you get it to come out, because this thing presumably come from something like this. So you know how to multiply it out, and now you have to decode it backwards, okay, like reverse engineering or something. You have to decode it backwards to make it look like that again. All right, so that's example 3. Please do example 3 as part of your homework. Next, let's look at page, we are now on, what does that say? Page 63, where we're looking at the perfect square. So that page 63 has an example 4. Okay, what is a perfect square? A perfect square is something that happens to be the square of itself. That is, let's see what's happening. Give me a second. Okay, here is an example as you see in the text, okay, where your equation happens to be something multiply, after you factor it, you notice that it's just something multiplying by itself. It might look like these are two very common perfect squares, and it would be good that if you memorize these things, because they show up a lot. Okay, so it's a squared plus 2ab plus b squared, or a squared minus 2ab plus b squared. And either way, they are going to end up equal to something squaring itself. As an example, let's look at example 4. Example 4, when you have 25x squared plus 20x plus 4, by the time you work this thing out like this, okay, the same way, then eventually you will figure out that, oh, this is just, this is some kind of thing squaring itself. But otherwise, besides it happen to be identical, there's no difference. You will try this trick and try different numbers until it comes out to be exactly right. So it's a trial and error thing to do. So please do example 4 as part of your homework. And then example 5 is even better, okay? Anytime that you see something in the form of two squares, right, this is extremely important, okay? Memorize this thing, because this will be repeated time and again. And so a squared minus b squared just happens to be a plus b times a minus b. This problem was done in the previous section when you try to multiply a plus b and a minus b, and then you realize stuff sort of cancels out and you only end up with a squared minus b squared, which is kind of nice and neat. And that is done all the time. So anytime you see something that's a perfect square, for example, look at example 5. We have factor 9x squared. What is that? 9x squared is 3x. Okay, the square root of 9x squared is 3x, because 3x times itself will be 9x squared. And the square root of 25 is 5. So then you have a situation where you have the difference of squares. That's what this thing is called. So then when that happens, it will be equal to the plus and minus version. See? So the answer to factoring this thing is 3x plus 5 and 3x minus 5. Being that the 3x is the square root of 9x squared and 5 is the square root of 25. So you follow the thing exactly. Now the next thing we need to consider is something of the cubic power. There are ways of specific formulas to factoring certain a couple of cubic formulas. That is, let's say you have the cubic formula like this, okay? The plus version, a cubed plus b cubed, is a plus b times a squared minus ab plus b squared. The reason we know that is if you multiply that stuff out on the right side, you will get this, because everything else in the middle cancels out very conveniently. And the same as the a cubed minus b cubed, the same principle applies. Everything in the middle, if you multiply it out, it will cancel itself out. Now please do that yourself though. I would like you to confirm what I just said by multiplying these things on the right side out, okay, to make sure that the book didn't mess up and give you the wrong information. So multiply the stuff on the right side to make sure that it does equal to the stuff on the left side. That would be a good practice. So having said that, now that we know that, what happens is, okay, So then we have, now that we have the formulas, we can use it to factor certain things. And just by following the formula, let's look at example 6, and which is, I will write that down here, example 6 on page 65. So we have, what was example 6? Okay, we have x cubed, okay, plus 512. And the formula we're following is the plus version. That is a cubed plus b cubed equal to a times b, a plus b and a squared minus ab plus b squared. Now this is a neat formula that we'll be using, not as much as the difference of squares. That one we use it all the time. This one we use it sometimes. Okay, so then we'll let a equal to x because they're both in cubed. Now 512. What is the cubic root of 512? That is that equals 8 to the power 3. 512. So in other words, this expression we're trying to factor is the same as x cubed plus 8 cubed. So following the formula exactly, this equal to x plus 8. Okay, I'm just following line by line. X plus 8 and then times x squared plus x times minus. That is there's a minus sign here. Where's my eraser? All right. So is x minus, okay, x times 8, and then plus 8 squared. And that can be rewritten slightly. We normally write numbers first, okay? So instead of x times 8, we write down 8x, and then 8 squared is 64, and that will be our answer. And that's how you follow this formula. And or the other one, the one that subtracts, a cubed minus b cubed, you follow it the same way. So please do example 6 and then example 7 where there's a minus sign. The only difference is with minus signs, then this becomes minus and this sign changes to plus. That way when you multiply stuff out, they cancel themselves out and you have a very neat little thing left when you're multiplying it. When you multiply this thing back, the minus sign is what makes stuff disappear, and you only got this stuff left instead of a whole string of stuff. So that is example 7. Next, we are going to look at example 8. Okay, example 8 is a matter of factoring stuff with fractional exponents. That's not done as much, but the principle is the same. Let's consider example 8. Let's say we have factors of let's see, that's on page 66, example 8, where we have 3x times, what is that? X plus 2 to the power minus 1/3. And then plus 4. And then x plus 2. And to the power 2/3. Okay, then why are we factoring this? Well, we want to factor something out. Right. And in any case, so what we're going to do is we're going to factor out just x plus 2 to the power minus 3. Okay, anything else? Nope, that's it. So we'll factor this thing out. To factor this thing out, so we have x plus 2 and then power minus 1/3. Then we have 3x left here, okay? And then plus, what happens here? Now, in order to factor something like this out, we need to multiply this thing by this thing right here, because that's how you factor. Like, so we're going to multiply this. So this is equal to 4 times x plus 2 1/3, okay? And times x plus 2 2/3. Now, the reason we're doing that is because when you this line right here has to be equal to this when you multiply it out, right? So when you multiply this by this, that will be that thing, right? And when you multiply this thing by that thing, these two will cancel, and you will end up with that again. See, that's why you need to multiply by 1/3 if you're going to pull this out, factor this thing out. So just so to factor out a negative fraction like that, what you're going to do is multiply it by the fraction, the same thing of the opposite sign. That is, if you're pulling out positive, then this one will have to be negative. Or if it's this right now, this is negative, so that one will be positive. So that when they multiply together, there will be just 1. Okay, and so because -3 plus 1/3 is 0, so then anything to the power 0 is 1. So anyway, so then we got this equal to at this point we have okay, that's 1/3. Okay, 2/3, they're the same thing. See, and if they're the same thing, then we are allowed to just become x plus 2. Okay, to the power 1. Which is just x plus 2, and then so our whole answer becomes x plus 2 to the power negative 1/3, and then we have 3x plus 4 times x plus 2, plus 2, yeah, and then you can simplify that part to be 7x plus 8. And that will be multiplied to this thing to be the answer, as your book shows. Although this isn't done as much, but yeah, I'm kind of surprised by that, but it doesn't matter. Okay, if your book wants you to do that, please do that as part of your homework, and that's how you go about it. When you pull a factor out, everything has to make sense. So you have to multiply something back in. So and then everything will come out reasonably well. So that is the end of this section for homework. Please do the problems that I listed earlier in the screenshot, okay? And that should be sufficient. And that's at the end of this section.